So now we're going to do another example of a three-dimensional solids that are representative of real-life situations. So what we have here is a cone. It looks like a right circular cone. And sure enough, it says here, a container has the shape of an open. An open, that means it's open up here. That means stuff can fall into it or drip into it. An open right circular cone as shown in the figure. This says above, but it's over here. It's probably from some other piece of paper. The height of the container, that's right, that's the height of the whole container, okay? So the height of the whole container here is 44 centimeters, okay? So that's 44. That's not this. This height right here is the height of whatever's in the container, okay? What could be a right circular cylinder? Well, like a coffee maker. A lot of coffee makers have cone-shaped drip reservoirs where you put the coffee grounds and then the water drips in and then goes through the coffee grounds and then it drips out the bottom. So this could be like a coffee maker or something. But the whole container is 44 tall. It says the diameter of the opening is 28 centimeters. That means that all the way across, so let's say that this is the center of the top, all the way across. It doesn't say the radius. It says the diameter of the opening is 28 centimeters. So all the way across is 28 centimeters. What does that mean? Well, that means that the radius then must be 14. Okay? So a radius of 14, a diameter of 28, okay? Sometimes they give that to you, they give you the diameter instead of the radius to trick you. So if the diameter is 28, then the radius is 14. So let's write over here, the radius is, actually I can't put R, I'm sorry. I take that back. I can't put R because they have already defined R as the radius of the water here. So let's just write a 14 here. That's fine. Okay. Then it says the water in the container has a depth. Well, it's not coffee then. I guess it's water. Has a depth of 15. So that means this depth right here, from here down to here, is 15. So H is equal to 15. And it says, what is the volume of the container? That's the whole container. Now, the volume of a cone, we know that the volume of a cone is 1/3 times the height of the cone times the area of the base. The area of the base is pi r squared. Now note that I'm gonna put H star on here and hang on, let me do something here. I'm gonna do R, well, let's call it R naught and H naught, because H is actually the water and R is the water. So we're gonna do R naught and H naught squared. This is the volume of a right circle, well, really a cone. And so we're going to say the volume of this overall cone, the whole container, is going to be 1/3 times the height of the container, which we were told is 44, times pi times the radius squared of the container itself, which is 14. So we'll put 14 squared. So this is the volume of the overall container. So we're going to do 1/3 times 44 times pi times 14 squared. So let's go to a calculator. Oh, where is it? There it is. Okay, so we'll do 1/3 times 44 times pi times r, which is 14, and then squared. All right, and so the volume of the whole thing is 9,031.032. Let's say 0.032. So the volume of the overall container is 9,031.032. All right, so that's the volume of the overall container. Okay. All right, so now it says, what is the radius of the cone of water in the container? So they're asking us to identify R here. Okay, so what is R? What is this distance right here? And this is very similar to a previous problem that we did where we used a proportion see what's happening here is this cone of water inside is proportional to the overall cone. It takes on the same similar shape as the overall cone. And therefore, the height of the water, 15, is proportional to the height of the container, 44. So 15 is related to 44, and then the radius of the cone of water is related to the radius of the overall container, which is 14. So what we can basically do here is create a proportion R over, so R goes with H, 15. So R over 15 is equal to, well, what's the radius of the big container? 14. So 14 over the height of the overall container is 44. So this radius is like this radius, and that's why we put R up here and 14 up here. This height is like this height. They're both heights of cones. That's why we put them in the same place in the fraction. One of them is the bottom of the small one, and one of them is the bottom of the larger one. And so this creates a proportion. And now all we have to do is multiply by 15 on both sides, 15, and we get R is equal to, we're going to multiply the 14 times the 15. So 14 times 15, that gives us 210. So this is 210 in the numerator, 210 over 44. Over 44, and now if we key that in the calculator, we'll do 210 divided by 44, and that gives us 4.773. 4.773. Also, look, it reduced the fraction from 210 over 44 to 105 over 22. So it's also the same thing as 105 over 22. So we can also say is 4.773. Why did I only do 3 decimals? It says round to 3 digits, okay? And in that other video we did with the trough, we wound up putting the fraction of the variable in the last part of the question. So I think that's what we're going to do here. We're going to put the fraction in when we do this last question here, the volume of the cone of water, okay? So it says, last part here, what is the volume of the cone of water? Well, the volume of the cone of water is going to use the same formula for a cone. It's going to be volume is equal to 1/3 times the height of the cone of water. The height of this cone of water is 15, so times 15 times pi r squared times pi. The radius we just learned is 210 over 44, 210 over 44 squared. And now let's key all that into the calculator. So we'll do 1/3 times 15, which, by the way, 1/3 of 15 is 5. So this really is 5, but we're going to key it in as the whole formula. Times pi times, and our, what do we have here? 210 divided by 44. Okay, close. And now times, oh, we got to square it, sorry, squared. There we go. So look, 1/3 height times pi times radius squared, and we get 357.811. This 5 is going to turn this 0 into a 1, so 357.811. See, 357.811. And that is our final answer. So our radius is 4.773. The volume of the overall container is 9,031.032, and the volume of water is 357.811.